Okay, so our first topic is about numbers, how to compute fractions. Okay, so computer numbers. This is a no XYZ. Okay, but the first problem I want to talk about is the notation point. Yeah, let's see. So if you are given, let me get my pencil. Okay, so if we are given a number like a 0.3, okay, 0.3. Now what's this is a notation. Yeah, if you put a bar there, means 0.3333. Now this is a rational number because the digits are repeated. Okay. This can be converted to a fraction, which is going to be 3/9. Okay, always put a 9 there if it's only repeated one digit. Right. So a fraction can be a rational number can be written as a fraction, or can be written as a number in decimal form was a decimal digits, repeated. Okay, was a repeating digits. Okay. Then if it's a 0.21, for example, and that will be 0.212121, right? So 2 digits will be repeated, and that will be converted to 21/99. Okay, so if we are given question, if you are given question like we'll find express 0.5 bar plus 0.2 bar as a fraction. Okay, and then what you can do is, well, you just change each of them to a fraction. So it's 5/9 and 21/99. Okay, now even to solve this problem, that do not have a common denominator. So in order to get the 99, you have to multiply the first one, 9 by 11. Okay. Okay. Then add them together. Okay. So this is going to be 99 and the 55. Sorry, 5 times 11. Yeah, 55 plus 21. So 76. And then 90/99. So you cannot simplify it. Okay. All right. So speaking of the numbers with the terminating decimal, some numbers will be will have a terminating decimal. So what kind of number will give you terminate decimal? Have a terminating decimal. For example, like 1/3, it's not right. It's repeating. But the 1/2 is 0.5, right? This is a terminated decimal. So what kind of integer? Okay, for what kind of integer 1 as a reciprocal is a terminate decimal? Okay, that's the question. Okay, the question is for what kind of positive integers so that their reciprocal is a decimal, a terminating decimal. Well, we find out is 1/n is a terminating decimal if and only if n is going to be only in the form 2p 5 times cube, 5 to the cube. Okay, so this is only if it contains other prime factors, then you will not get terminating decimal. Okay, for example, if it contains 7, No, you cannot. Okay. So if we ask the question, how many positive integers less than 40 have their reciprocal terminating decimal? Okay, and to solve this problem, you just needed to find out all the numbers in this form, which should be less than 40. Okay, which less than 40, and then you just PQ are integers, right? So you can assume P0, right? Then you get n is going to be 1, 5, 25. Okay, that's it, right? Then you look at P equals 1, n equals just multiply 2, right? 2 and the 10. Okay, so you can 2 times 25 is going to be already. So P equals 2, n is going to be 4, right? And the 4 times 5 is 20. Okay, so 4 times 5 is 20. Just multiply the first line, right? By 2. And then P equals 3, n equals 8. Okay, then after that, 8 times 5 is already 40. So P equals 4, n equals 2 to the 4th power, and still less than 40, right? 16. And n equals 5, 2 to the 5th, 32. That's you stop here. Then you count all of them. So you have to find a way to list all possible solutions. Okay. Now our next notation is about the nth root. Okay, about the nth root of a number a. Okay. Okay, what's the mean nth root? What does it mean nth root? Just we assume that this number a is positive. Okay. So if a negative, it's a little bit subtle. So we're not going to deal with this right now. Okay. So the nth root, this is also denoted by this form, a to the power 1 of n, the same notation. Okay, this is going to be, is the positive number, okay, x such that x to the power n equals a. Okay, well, there's only one number satisfying this. That number is going to be denoted by the nth root of a. So this is usually it's not a rational number in general. So what is square root 2? Okay, this is the second the second root of 2. Okay, so this is a number, okay, such that its a square is going to be 2. Okay, so that's obvious, right? But that's the definition of the square root 2. Now, how big is this number? Can we express as a fractions? No. So this 2, square root 2 cannot be expressed as a fraction of 2 integers. And it is an irrational number. Now, it's not easy to prove. Okay, you can try. Okay, how to prove? Why not? Right? Then in mathematics, when you prove something, you will just assume. It's assume it is a fraction. Then you get a contradiction. So that assumption is wrong. Okay, that's how we prove. Now, how big of this number? Of course, you can use a calculator to estimate. Right? If you already know the Pythagorean theory, and this is just equal to the length of the diagonal, you need to square. So, okay. So that is how big of the number. Then you can talk about nth root of more general number. Okay. Now, how do we define m to the n if we have a irrational number? But that's defined. Yeah, this is another definition. Okay. First of all, you have to make sure the nth root is defined, then n to the mth power. So in other words, it's a to the 1 of n times a to the 1 of n, a to the 1 of n. Okay, that's a notation. Okay, so if I ask you to compute 8 to the 3, 8, yeah, 2 over 3. Okay, so 8 2 over 3 is 8 to 8, 1/3 of the third root of 8 and the square. So you figured out the third root of 8 first. The third root of 8 is going to be 2. That's why it's going to be 4. Why third root is 8 is 4? Because we know that 2 cubed is going to be 8. That's why the third root of 8 is going to be 2. Because by definition, that's only one number. Remember, right? That's only one number. Its cube is going to be 8. That number is denoted by third root of 8. But we already know, on the other hand, we already know that 2 cubed is going to be 8. Okay? Yeah. All right. Yeah, let's do one more exercise. 27 to the 2 over 3, right? 27 to the 2 over 3 is going to be 27, 1/3 root of 27, and the square. 1/3 root of 27 is also denoted by the third root, 27 to the 1/3. It's also denoted by this, okay, notation. Okay, so that's why 3 times 3, actually this is going to be 3 because y3 cubed is going to be 27. So 3 squared, which is 9. Great. Now let me mention some basic formulas we needed. Okay, the formulas we're going to use. Okay, a to the alpha times a to the beta, and those is going to be a to the alpha plus beta. Okay, that's the first formula. The second formula is a to the negative alpha. This can be negative. It's going to be 1 over a to the alpha. Okay, then you can talk about a to the alpha divided by a to the beta. All right. Now, how do you simplify? So this can be written as a to the alpha times a to the negative beta. Then you can add them together. But if you add it together, just alpha plus negative beta. Okay, right? And you can also express it in another form. You can move a to the alpha to the denominator. Okay, so you can get beta minus alpha. So it's the same. Okay, so there are many ways to express. Another important thing is a to the alpha, then to the beta is a to the alpha times beta. Okay. What else? Oh, 2 more. Okay. A b to the alpha is going to be a to the alpha, b to the alpha. Then a over b to the alpha equals a to the alpha, b to the alpha. Okay. So those are the formulas we should know, and we're going to use that to simplify it. For example, square root 12, right? This is a 12 to the 1/2. Okay, another thing, right? And 12 is going to be 3 times 4. Okay, so you can express it in the form like that. Which formula we're using? We use this formula, right? To here. Okay, then 3 to the 1/2. 4, the square root of 4 is going to be 2. So it's 2, and then you can write the square of 3. This is another thing. It takes too much time, but that, that's how do we get that? Step by step. Okay. All right. So let's do the next problem. Evaluate the third root of 0.00040 here, 81, times the third root 0.009. Okay. Okay. Now, without using calculator, if you use the calculator, it's even cause more troubles. The third root. You have to use a scientific calculator to estimate, but we want to get exact value. Okay. How do you do that? Very first step, you have to express this number in the form, okay? And how many digits after that? It's going to be 81 times 10 to the negative 6. You have, yeah, 6 digits there, okay? Okay, and 0.009 is going to be 9 times 10 to the negative 3, okay? Right, it's 9 divided by 1,000. All right, this is then we're going to do the computation. 0.0000081. Okay, that's going to be, first of all, 81 times 10 to the negative 6, the 1/3. And here 9 times 10 to the negative 3, and the 1/3. Okay, I can put them together. And you have a negative, right? Put the inside. Then 81 is 9 squared. So it's 9 cubed here. 10 to the negative 9 to the 1/3. Now, what is the next formula we're going to use? We are going to use, we're going to use we're going to use this formula again, separate them. Okay, and each of them, 9 cubed to third root of 9 cubed is going to be 9, right? Well, we're going to use this formula here, this formula, okay? Alpha plus beta, alpha times beta. So 3 times 1/3 is just 1. And then negative 9 times 1/3 is going to be negative 3, okay? So you can also change it back to the original form, okay? So that's what they get. Surprise, right? You get some kind of similar number, like 0.99, okay? All right, so those problems are from the previous math counts, okay? So the next one is, what is the value of okay? Yeah, I'll give you a half minute to think about. If you have an answer, post it, okay? Okay. All right. Great. I got the answers from the student. I'm happy to see that. All right. So to solve this problem, you see you have 4 identical, you have 4 identical 4 to the power 11, okay, right? Then it'll be 4 to the 1 plus 11 to 12. Then you get 4 to the 12 times quarter, which is 4 cubed. 4 cubed is 64. Okay, this is how do we get. All right. So our next problem is to simplify 2 to the 2008 minus 2 to the 2006 divided by 2 2007. Okay. Now, each of the number is very large. Okay. To simplify this, you needed to get, well, 2 to 2008 and 2 to 2006. You have to separate that number. It'd be 2 to the 2006 times 2 squared. Then you can simplify it. Okay. So the numerator have a common factor here. 2 is 4 minus 1. So actually it's 3, right? 2 squared minus 1 here. Okay. Yeah. All right. So 2 to the 2006, right? And the numerator, the denominator, you can write it like this. Multiply 2. Okay. 2 squared minus 1 is 3. So those two cancel out. It'll be 3 over 2. Yes. Good. Good job. Okay. So now I'm going to ask you to do the next one. Simplify 2 to the 307 minus 2 to the 301 divided by 7 times 2 to the 300. Okay. Yeah, so take a look at this. How do you simplify? Wow. So you got 256 over 7. All right, let's take a look, okay? 2 to the 307 can be written in the form like this, right? Okay. So what we get here is, okay, so it's 7 times 2 to the 300. So 2 to the 300 and then divide by 2 to the 300, and 2 to the 301 divided by 2 to the 300 is going to be just 2. Okay, now question, how do you simplify it quickly? My suggestion is, okay, I change 7 to the 2 cubed minus 1. And the numerator is 2 cubed square minus 1 square. So numerator will be 2 cubed minus 1, 2 cubed plus 1, divided by 2 cubed minus 1. So actually, the formula we are using here is a squared minus b squared is a minus b, and a plus b. Okay, so this cancels out. So all you have to do is 2 times 9, which is 18. Okay, if you do the computation carefully. Okay. All right. Now, for fractions, add them together. We have a formula a over b plus c over d, right? And plus minus, you have ad plus minus bc and bd. And if you do the multiplication, a over b times c over d, you just a, c, and then b and d, right? For example, 3 over 2 times 5 over 7, right? Then just have a 2 times 5 is 10 and 21. Okay, maybe there are some common factors can cancel, but for this one you don't have. Now, most interesting is the formula is this one: a over b divided by c over d. How do you simplify? Okay. Well, the first thing you have to do is you turn this upside down, d over c. Okay. Then you have an a, d, b, c. The special case, let me talk about special case. The special case, okay, the special case, actually there are 2 special cases here. Okay. So AB over C, okay, that's only 1 letter there. But this can be viewed as 1 over C, right? So that is just A over BC. Okay, I'm talking about formulas here. So for example, you have a 2 over 3 divided by 5. How do you do that, right? So it's going to be 2 over 3 multiplied by 1/5. Okay, so division can become multiplication. So it's 2 over 15. Okay, so when you do the computation, you have to be very careful about this through the algebraic rule. Another one is A over B and C. Okay, now in this case, and this is A, and the C over B. Okay, because turned upside down, and that would be AC over B. All right. Yeah. Well, okay. So it's 2 over 3 over 5. When you do computation, it's 2 times 5 over 3. That's 10 over 3. Okay. So be careful when you simplify. You have to follow these rules. Okay. So let's try to simplify the following: 1 over 1 minus 1 over 1 minus 1/2. Oh, oops, right? That's very complicated number. Well, you have to do step by step. The first step is 1 minus 1/2 is 1/2 here, right? Yeah, this part. So it is going to be 1 over, 1 divided by 1/2 is 1 times 2. So just 2. So answer is -1. Yes, they're very fast. All right, so I'm going to ask you to do the next one. Don't make mistakes, okay? 1 plus 2 plus 3 plus 1/4. Okay, try this. I hope eventually you can get a correct fraction. That fraction, I tell you, should be less than 1. Hi, Jasmine. Haven't seen you for a long time. Yeah, Grant, you did a good job. I'm happy to see that. Alex, me. Okay. All right. So sounds like you guys are doing a good job. And yeah, to do this, you have to do step by step, right? You have to add 3 plus 1/4, which is going to be, right? It's going to be 13 over 4. You can then have 4 over 13, right? Then add them together. 2 plus 4 over 13 will be 26 plus 4 will be 30. You can do company in mind, right? Then it'll be 13 over 30. Right? Then finally, 30 plus 13 is going to be 43. So the answer will be 30 over 43. Okay, good job. Right. So now I'm going to talk about another notation called the so-called n factorial. N factorial is 1 times 2 times 3 times 4 all the way to n. Okay. Now from this expression, yeah, the one previous that is n. So this part can be also denoted by n minus 1 factorial, right? Okay, so you can read this n minus 1 factorial times n. That's why, 7 factorial is going to be 6 factorial times 7. Okay. Okay. So if you know this, then you can simplify 8 factorial over 2 factorial times 6 factorial. Okay. How do you do that? Well, you don't need to multiply them out 8 factorial. So you use 8 factorial is 6 factorial times 7 times 8. 2 factorial is 1 times 2, and 6 factorial. So 6 factorial canceled out. Okay, then this is canceled out. So you get 4. Then you get 28. Okay, so that's how do you do that. All right. Okay, I'm going to ask you to do the following problem. 9 factorial minus 8 factorial over 9 factorial plus 8 factorial. Okay. So what is the answer? 1 cannot be 1. If it's 1, then the numerator should be equal to the denominator. Benjamin, yeah. Right? Common sense. When you look at answer, okay, look at the origin problem, right? That cannot be equal. Only when the numerator and denominator equal, but then clearly the numerator is less than the denominator. So your answer will be less than 1. Your answer will be less than 1. I already said that, right? Yes, Eric. 45. Yeah. All right. So that's it, right? Yeah. So 9 factorial is 8 factorial times 9. Okay, then here 8 factorial times 9 plus 8 factorial. What you get here, you take 8 factorial out, then you simplify. Okay, so here's 8 factorial, 9 minus 1, 8 factorial, 9 plus 1. So 9 minus 1 is 8, 9 plus 1 is 10, so 4 over 5. All right, so we're done with this. Okay, now let me talk about another important formula. We find out if you try to combine those two together, what do you do? Right? N times N plus P. then n plus p minus n. So the numerator is p over n, okay, over n times n minus p. So that means if you have this, you can separate them, right? And then you have to divide by p, okay? So, so the special case is n times n plus 1. P is going to be 1, so 1 over n minus 1 over n plus 1. Now that's very important decomposition of the fraction, okay? Okay, so if you are given 2020 times 2021, you can change it to the 2020 minus 2021. Okay. Okay, so got this idea. So let's do the following problem. Simplifying 1 over 1 minus times 2, then 2 times 3, 3 times 4. And here's 2020 times 2021. Okay. Now you have, how many terms you have? You have a 2020 terms. You you cannot, okay, you cannot do the 2020 additions. It's impossible, and it's easy to make mistakes. But when you look at each fraction, you find out the denominator is a product to consecutive numbers. That's great news. So in order to simplify, you make it more complicated. So it's going to be 1 over 1 minus 1 over 2. And 1 over 2 minus 1 over 3. 1 over 3 minus 1 over 4. And keep going. 2020 minus over 1 over 2021. Then you see that, great. Okay. That all of them canceled out. Okay. So the terms in the middle. See, this is tricky. Okay. You are going to learn some tricks here. Okay. They all canceled out. What is left is 1 minus 1 over 2020. So the final answer will be 2020 over 2021. All right, that's good. Okay. So I'm going to ask you to do the next one. Okay. Make sure you're familiar with the formula I just mentioned, right? So 1 over 3 times 5 plus 5 times 7 plus 1 over 7 times 9, and keep it going. 99 times 101. Okay, be careful when you're trying to solve this. I think you That was a mistake here. You see, remember, yeah, Erica, good. Oh, James, yeah. Okay, 104 now. Okay. Now that's subtraction, not multiplication. Come on. So got so many different answers here. All right. Eric, you're doing good. Okay. Erica, not Eric. Okay. All right. So the point is, first of all, let's take a look at this. It's not going to be 1/3 minus 1/5. They're not equal. If you combine them together, you get 5. You get on the numerator 5 minus 3. 5 minus 3 is 2. So they're not equal. So you have to divide by 2 here, divide by 2 here. Then you get, okay? So the above decomposition is going to be 1/2, 1/3 minus 1/5, plus 1/2, 1/5 minus 1/7. You have to double check that, don't just assume that's going to be difference, okay? And keep it going. It's 1/2, 1/99, okay? So anyway, you still can cancel out the terms, right? Let me cross it, right? This cancel out, this cancel out. All the term in the middle will be canceled out. What is left is 1/2 times 1/3 minus 1/2 times 1/1, right? So therefore, something says 104, right? That just use addition. No, okay, it's going to be 1/3 minus 1/1. Okay, it's going to be 1 minus 3, 3 times 100. Okay, so the answer will be, okay, yeah, so it'll be 98 divided by 2, 49. Okay. All right. Yes. It's subtraction. You forget, this is last term, that's a minus sign there. Okay. So we have to learn how to add the many terms together. Okay. And there was, probably already know the formulas, right? So we know that 1 plus 2 plus 3 all the way to the n, it's going to be n times n plus 1 divided by 2. Okay, how do we get this formula? Right? How do we get this formula? I'm going to show you proof here. This idea, you let s to be 1 plus 2 plus 3 all the way to n. Okay. Then this, you can also reverse the order. Okay. Once you reverse the order, you add them together. Vertically, add them together. So if you add them together, this side is 2s. This side is n plus 1. You always get n plus 1. Always get n plus 1. N plus 1. Okay? How many of them there? N. So n times n plus 1. Then you solve for s. This is how do we get the formula. Okay? This is how do we get the formula. Now there are other two formulas, not easy to get it, but I want to mention that here. So 1 square, 2 square, 3 square, all the way to n square, which is going to be, actually is going to be 2n plus 1 over 3, and times n times n plus 1 over 2. You see? So this part are the same, but there's additional term here. We can look at it, compare this, right? Yeah. Okay. There's addition term, 2n plus 1 divided by 3. I don't know. Okay. Then we have n 1 cubed, 2 cubed, 3 cubed. And we find out this is going to be n times n plus 1 square. Well, that's more interesting, right? But how about 1 to the 4th? Probably we have a formula. You can find on the internet, yeah. But question is whether you can always get a formula, right? Get a simple expression. We don't know. There's a famous mathematician called Ramanujan. Okay, there's some even movie about him. An Indian famous mathematician. Maybe you can find the time to watch it. And he's very genius. I don't know. He can talk to the God. Okay, he can write down many formulas without proofs. Okay, and people trying to figure out how to get his formulas. He said, "Come from dream." Okay, from the dream. Okay, so yeah, there's a movie about it. Oh, you see that? Great. Yes, and it's hard to believe. Yeah, but there's such person there. Okay, he's from very poor family. I think he began with they're trying to save money, so rent their part of their house to two college students. And then when he was a child, and he learned the math from them at the very beginning, then he quickly understand lots of mathematics. All right, so those are the formulas we need. So let's do the next problem. Uh, 1 plus 2 plus 3 plus 4. Okay, let's try this. Well, it's not product, right? That's fine. But you see that in an arbitrary term here, actually it turns out to be the product to consecutive numbers. Think about that. So 1 plus 2 plus 3 all the way to k. That is going to be half of the k times k plus 1, right? If you're using this formula, then the above sum is what? If I only have a 1, you can have 1 times 2 divided by 2. You have 1 plus 2 is 2 times 3 divided by 2. The third term will be 3 times 4 divided by 2, right? The fourth term will be 4 times 5 divided by 2. The last term will be 100 times 101 divided by 2. If we can express in that form, you are able to solve the problem already. So you put 2 on the top. 2 on the top. Okay. Now this one, at least we can prove it, right? Yeah. And then you take 2 out. And what do we do? 1 over 1 minus 1 over 2. 1 over 2 minus 1 over 3. 1 over 3 minus 1 over 4. Keep it going. 100 minus 101. All of the terms in the middle canceled out. Cancel. So you only get the 1 over 1 minus, right? Yes. So now you get 100 over 1. So you get 200 divided by 1. Okay. So that's our answer. All right. Yeah, but if you add all the numbers together, we can even get a general formula. Probably this formula is already show up in the Amaraj's notes. Okay, published. So the general formula is it's a 1 over 1, right? Plus 1 over, right? All the way to 1 plus 2, all the way to n. Okay. And you probably we have time. Let's find the formula, right? So instead of 100, you have an n, right? And then you can get a sum, actually. And each of them will be 2 over 1 times 2, right? 2 over 2 times 3, right? 2 over 3 times 4. And the last one is 2 over n times, right? And then take 2 out. So you get n minus 1 over n plus 1, okay? Finally, you get a formula. So you only have 2 terms left. And the numerator will be n plus 1 minus 1 is n, okay? So the answer will be 2n n over 1, and over n plus 1. So my question is, now this number is slightly less than 2, but it's getting close to 2, right? Right? So this, we need some kind of concept limit. So this is clearly less than 2. Do you agree? Why? Because n over n plus 1 is always less than 1, okay? So no matter how many terms you add, you never get a number larger than 2, okay? You never get a lot, but it's getting close to, I believe that. If n is 1 trillion, 1 trillion over 1 trillion plus 1, I think it's almost equal to 1, right? Then, so this is a concept of a limit, okay? Yeah. So, well, please do not type anything on the screen, okay? All right, so the last problem, simplify 1 minus a quarter. Yeah, Richard, you're not bored. If you do that, I will tell your father, okay? All right, so let's work on this. Wow, this is the most challenging problem. Each term is slightly less than 1, but you have so many terms here. But what do you find out? The denominator here is always a product, is a perfect square. Okay, so let's look at the perfect square. So it's n k square, right? What are we gonna do with this? Right? So you're going to get k square and k square minus 1. Now you understand that. Otherwise, the question is how do you solve the problem, right? So that's going to be k minus. Whenever you see k square minus 1, you should express a k minus 1, k plus 1 over k square. Okay, that is the expression. All right, so our problem here is 1 minus 2 square, 1 minus 1 over 3 square, 1 minus 1 over 4 square. And here is going to be, I think, a 50 square, right? 50 square, good. All right, so 50 square. So what? So I cannot multiply them out, just too many terms, right? What I'm trying to do is I'm trying to add those 2 terms inside each parenthesis. So I get 2 square minus 1 over 2 square, 3 square minus 1 over 3 square, 4 square minus 1 over 4 square, and the 50 square minus 1, 50 square. Then what? Don't worry. All right, so what you get here is in the denominator, you have a factorial, right? 2 square, 3 square, 4 square, 5 square, 50 square, okay? Don't worry. Now, 2 square minus 1 can be written as a factor. 2 minus 1, 2 plus 1. Okay, 3 minus 1, 3 plus 1. 4 minus 1, 4 plus 1. 50 minus 1, 50 plus 1. Okay, then I think you're almost done. Okay, what I'm going to do is I will consider those, put them together first. Okay, I change the different colors. So then those will be put together. Okay, then you can solve the problem. All right, so here let's do it. 2 square, 3 square, 4 square, 5 square, 50 square. So 2 minus 1, 3 minus 1, 4 minus 1, and 50 minus 1. Then another group, 2 plus 1, 3 plus 1, right? 4 plus 1, and 50 plus 1. Okay, what do you get? Not too bad. The numerator here is 1 times 2 times 3, and 49. Another group, 3 times 4 times 5, 51. And here is 2 square, 3 square. 2 square, 3 square can write as 2, 3, all the way to 50. 2, 3, all the way to 50. I can separate, right? Now you know how to do it. You know how to simplify. Okay. Most of them are gone, right? Only 50 is left here. And here, they're all gone. And then, no, I have to keep a 2 here. Then I have 51. Right? So the answer is 51 over 100. All right, this is the most difficult problem. It's not easy to figure out at the very beginning. Okay, but I hope you understand. This is from math count. Okay, now you're you're going to get this time. The first time the set of homework is going to be more like 30 problems. Okay, in the following chapters, you only have 15 problems because this is still pretty elementary. No X, Y, Z, right? It's not abstract. Okay, so dealing with the numbers. I hope you learn those tricks today. Okay, through the examples and also doing homework.